Ever driven on a cracked, bumpy road and wondered how it gets repaired? Do roads need to be completely rebuilt every time they wear out? Not always. Road rehabilitation techniques restore damaged roads, making them safer, smoother, and more durable without full reconstruction. In this guide, we'll explore why road rehabilitation is important, common road issues that need repair, step-by-step rehabilitation process, key methods, asphalt overlay, cold and hot recycling, milling and full-depth reclamation, FDR. Everything explained clearly. An easy way to understand in less than 20 minutes. Let's dive in. Welcome to Civil Guru, where we bring civil engineering to life in multiple languages, including English, Spanish, French, Portuguese, Arabic, Hindi, and Tamil. Please select your desired language from the playlist or from links given in description. If you find this video helpful, please like, share, comment, and subscribe to our channel. And if you'd like to support our work, you can now contribute through Super Thanks. Even a small gesture makes a big difference and helps us create more high-quality educational content. What are all the common road issues that require rehabilitation? Over time, roads wear out due to traffic, weather, and material aging. Some common issues include cracking, fatigue, alligator, and longitudinal cracks weaken pavement. Potholes. Water infiltration and heavy loads create deep holes. Rutting. Depressions in wheel tracks due to weak pavement layers. Surface wear. Loss of aggregates reduces skid resistance and safety. If these problems are ignored, roads deteriorate faster, leading to higher repair costs later. Why is road rehabilitation necessary? Not every road requires widening or additional lanes. When expansion isn't needed, but the pavement deteriorates, rehabilitation offers the most efficient and cost-effective solution. Key benefits: enhances safety, reduces the risk of accidents caused by potholes, cracks, and uneven surfaces. Extends lifespan, strengthens the existing pavement, delaying the need for full reconstruction and reducing maintenance costs. Improves driving comfort, provides a smoother ride, enhancing fuel efficiency and vehicle performance. Eco-friendly. Recycling techniques reuse 50 to 60% of existing materials, minimizing waste and reducing environmental impact. Faster execution. Takes significantly less time compared to complete road reconstruction, reducing traffic disruptions. Cost-effective. More economical than new construction, as it reuses materials and requires fewer resources. Road rehabilitation process, step by step. Step 1. Preliminary survey and damage assessment check. Engineers inspect using laser scanning, drones, and core sampling. Cracks, deformations, and drainage failures are identified. Step 2. Selecting the right rehabilitation technique. The best method is chosen based on damage severity, traffic load, and budget. Step 3. Surface preparation cleaning, milling if needed, and leveling for better adhesion. Step 4. Structural strengthening base stabilization using 2 to 3% cement, lime, or asphalt binder for FDR. Step 5. Resurfacing applying asphalt overlay, recycled pavement, or concrete panels. Step 6. Quality control and drainage improvement compaction, slope adjustments, and drainage enhancement. Step 7. Final finishing adding road markings, safety barriers, and traffic signs before reopening. Key road rehabilitation methods. There are 4 main types of road rehabilitation techniques. The first method is asphalt overlay, which is used to restore the road surface without complete reconstruction. It is further classified into 2 types. 1. Direct laying. 2. Milling and resurfacing. The second method is cold recycling, an eco-friendly technique that reuses existing pavement material at ambient temperature. It is divided into 2 types. 1. Cold in-place recycling, CIR. 2. Cold central plant recycling, CCPR. The third method is hot recycling, which involves heating and rejuvenating the existing asphalt to restore its strength. This method is categorized into: first, hot in-place recycling, HIR. Second, hot central plant recycling, HCPR. The fourth method is full-depth reclamation FDR, a process that rebuilds the road foundation by pulverizing the existing pavement and stabilizing it with additives. It is classified into three techniques. 1. Mechanical stabilization. 2. Bituminous stabilization. 3. Chemical stabilization. Now, let's explore each method in more detail. Asphalt overlay. Instead of a full reconstruction, an asphalt overlay is used to restore pavement functionality and extend its lifespan. One approach to this is the milling and resurfacing method. In this video, we'll take you through the step-by-step process of asphalt overlay using this method, explaining how it works and why it's an effective road rehabilitation technique. Step 1. Pavement evaluation and preparation. Before applying an overlay, engineers assess the existing pavement condition through visual inspections, core sampling, and deflection tests. If the surface has minor cracks and wear, an overlay can be applied directly. If there are deep cracks, potholes, or structural issues, pre-overlay repairs are necessary. Once the evaluation is complete, the road is cleaned and prepared for overlaying. Step 2. Milling, if required. In many cases, the old pavement is milled before placing the new asphalt layer. Milling removes the damaged surface to create a smooth and even base. It maintains curb and drainage levels, preventing water pooling. The milled asphalt is recycled, making the process environmentally friendly. Milling depth depends on the severity of damage, typically ranging from 25 mm to 100 mm, 1 to 4 inches. Step 3. Pre-overlay surface treatment. To ensure a strong bond between the old pavement and the new overlay, additional treatments are applied. Crack filling. Large cracks are sealed to prevent reflection cracks in the new layer. Pothole patching. Deep potholes and ruts are repaired before overlaying. Leveling course. A thin layer of asphalt is used to correct surface irregularities. Tack coat application. A bonding agent is sprayed to improve adhesion between layers. Proper surface treatment ensures the overlay lasts longer without premature failure. Step 4. Asphalt overlay placement. Once the surface is ready, the new asphalt mix is laid using an asphalt paver. Hot mix asphalt, HMA, is transported from the plant and evenly spread over the road. A paver screed levels the mix, ensuring uniform thickness and smoothness. The overlay thickness typically ranges from 25 mm to 75 mm, 1 to 3 inches, depending on the pavement condition and traffic load. The new asphalt layer improves ride quality, restores skid resistance, and enhances durability. Step 5. Compaction for strength and durability. Immediately after placement, the asphalt is compacted using rollers to achieve proper density and strength. Proper compaction ensures the overlay withstands traffic loads and environmental conditions. Step 6. Joint and edge. Sealing. To prevent water infiltration and edge deterioration, the overlay edges and joints are sealed using bituminous materials. Step 7. Pavement markings and traffic reopening. After compaction, the road is allowed to cool and gain strength before opening to traffic. The road is inspected for any surface defects or irregularities. Once the overlay has properly set, the road is reopened for vehicles. Cold recycling method. What is cold recycling? Cold recycling is a road rehabilitation technique where the existing asphalt pavement is milled, crushed, mixed with binders, and relaid without heating the material. Cold recycling is performed at ambient temperature, making it eco-friendlier and more cost-effective. The first method, cold-in-place recycling, CIR, step-by-step execution. In cold-in-place recycling, the milling, crushing, mixing, and paving all happen on site using specialized recycling machines. Step 1. Surface preparation. A preliminary survey determines the depth of milling required. The road surface is cleaned to remove dust and debris. If cement stabilization is needed, dry cement is spread on the pavement before milling. Step 2. Milling and material collection. A milling machine removes the damaged asphalt up to a required depth, typically between 5 to 15 centimeters. The milled material is crushed and screened directly on site to achieve the correct particle size. Step 3. Mixing with stabilizers. bitumen or cement. The crushed material is mixed with binders using a recycler stabilizer machine. If bitumen emulsion is used, bitumen is sprayed evenly across the material. Additional water is added for moisture control. If cement stabilization is used, cement, typically 2 to 4%, is mixed with water to improve strength. Step 4. Spreading and compaction. A grader spreads the stabilized material evenly. A vibratory roller performs initial compaction. A pneumatic tire roller provides final compaction, ensuring a durable surface. Step 5. Surface treatment and curing. A seal coat or tack coat is applied for better bonding. The surface is cured for at least 24 hours before adding the final asphalt layer. Cold in-place recycling is a quick and cost-effective solution, especially for rural roads and urban streets with moderate distress. Now the second method. Cold Central Plant Recycling, CCPR, step-by-step execution. In cold central plant recycling, the existing road material is transported to a central plant, processed, and then returned to the site for paving. Step 1. Milling and material transport. The old asphalt pavement is milled and loaded onto trucks. The milled material is transported to a central recycling plant for processing. Step 2. Crushing and screening. At the plant, the material is fed into a crusher to break down large particles. It is then screened to remove fine particles and achieve proper grading. Step 3. Mixing with binders, bitumen or cement. Bitumen emulsion, typically 2 to 3%, is added to improve binding properties. Alternatively, cement, 2 to 4%, can be blended for added strength. Water is added to achieve the correct moisture content. Step 4. Homogenization and storage. The mixture is blended in batch mixers or drum mixers to ensure uniform consistency. The processed material is stored briefly before transportation. Step 5. Transport back to site and paving. The processed material is loaded onto trucks and delivered back to the roadside. A paver spreads the material evenly across the road. Compaction is done using rollers to achieve the desired density. Step 6. Final surface layer application. A thin asphalt layer or chip seal is applied over the recycled base. The road is open to traffic after proper curing. Hot recycling method. What is hot recycling in road rehabilitation? Hot recycling is a technique where existing aged asphalt is heated, softened, mixed with fresh bitumen and additives, and then relayed as a new pavement layer. The first method. Hot in-place recycling. HCPR process. Step 1. Heating the existing pavement. Specialized machines heat the existing asphalt surface to soften it. The heating depth typically ranges between 30 to 50 millimeters, depending on the pavement condition. Step 2. Scarification and mixing. The softened asphalt is scarified, loosened, and mixed with new bitumen. Anti-aging rejuvenators may be added to restore lost flexibility in aged asphalt. What are anti-aging rejuvenators in asphalt recycling? Over time, asphalt oxidizes due to UV rays, oxygen exposure, and traffic loads, making it brittle and prone to cracking. Rejuvenators help reverse this aging process by improving the viscosity, elasticity, and bonding properties of recycled asphalt. Different types of rejuvenators are available, and their selection depends on the mix design requirements to ensure durability and flexibility. Step 3. Laying and leveling the asphalt. After mixing, the heated and rejuvenated asphalt is fed into an asphalt paver. The paver screed evenly spreads and levels the asphalt to achieve the desired thickness and road profile. Automatic grade and slope control systems ensure consistency in thickness, preventing uneven surfaces. Step 4. Compaction. Once the asphalt is laid, rollers compact the surface to increase density, strength, and durability. Proper compaction prevents air voids and moisture infiltration, reducing the risk of early pavement failures. Now the second method, hot central plant recycling, HCPR process. This hot recycling is also performed at an asphalt mixing plant for larger projects. This process involves: Step 1. Milling and transport. The top layer of asphalt is milled, collected, and transported to the plant. Step 2. Crushing and screening. The reclaimed asphalt is crushed into smaller particles and screened for size consistency. Step 3. Mixing with fresh materials. The recycled asphalt is heated and blended with new bitumen, rejuvenators, and aggregates to enhance performance. Step 4. Transportation and laying. The processed asphalt is transported back to the site and applied as a new overlay. This method allows higher control over mix design and is widely used for high-traffic roads. Milled asphalt is transported to a plant for processing. It is mixed with 4 to 5% bitumen content for added durability. The final mix is laid back on the road using paving equipment. This method is best for roads with deeper structural damage. Full depth reclamation, FDR. When the base is unstable and road's foundation is weak, then the full depth reclamation, FDR, is done before laying asphalt. It is a sustainable technique where the entire existing pavement, including the asphalt and base layers, is milled, mixed, and stabilized on site to create a solid foundation. Instead of hauling away old materials, everything is reused, making this method both cost-effective and environmentally friendly. But how is it done? Let's go step by step. Step 1. Pre-assessment and planning. Before starting the process, engineers assess the condition of the existing road, checking for cracks, strength, and drainage issues. The required depth of reclamation is determined, usually between 150 to 300 millimeters, depending on the road's condition. Based on the material properties, a suitable stabilizing agent is selected. This could be cement, lime, asphalt emulsion, or other additives. Step 2. Pulverization of existing pavement. A specialized machine called a reclaimer is used to mill and pulverize the existing asphalt and base layers to the required depth. The pulverized material is left in place, ready for stabilization. Step 3. Addition 2 to 4% of stabilizing agents. Depending on the project requirements, a stabilizing agent is spread evenly over the pulverized material. For mechanical stabilization, additional aggregates may be added. For bituminous stabilization, asphalt emulsion or foamed asphalt is mixed in. For chemical stabilization, cement, lime, or fly ash is blended with the material. A second pass of the reclaimer machine ensures a thorough mix of the stabilizer with the pulverized material. Step 4. Grading and shaping. Once mixed, the stabilized material is graded and shaped using a motor grader to achieve the required profile and slope. Water may be added if necessary to maintain optimum moisture levels for compaction. Step 5. Compaction and curing. Next, vibratory rollers compact the material to achieve maximum density and strength. If a chemical stabilizer like cement is used, the material may require a curing period of 3 to 7 days before the final surface layer is applied. Step 6. Application of the final surface. Once the stabilized base is ready, a new asphalt overlay or chip seal is applied to create a smooth and durable driving surface. Final compaction is done, and the road is tested to ensure quality and strength. And just like that, the road is fully rehabilitated, without removing and replacing tons of materials. If you enjoyed this video, subscribe now and share with your friends. Also, don't forget to press the bell button. Thank you.